Okay, so hi guys, welcome back to my channel. So today we are going to learn about this Singleton pattern, and this is going to be the last video of this creational design pattern. Next we'll be starting with behavioral or structural based on the priority. Okay, so in this video you all will be getting a bit essence of thread, multi-threading, race conditions, and a bit of concurrency and parallelism. Okay, why I'm saying this, because very soon I'll be starting a playlist where I'll be explaining in and out of the thread concepts. Okay, so just stay tuned. So let's start the Singleton pattern by seeing what it actually intend to do. Okay, then we'll see the definition, then we'll move to the code. There will be a layer wise code. Okay, so for the first time I'll be showing you some code, then we'll see why this is the bad behavior and we'll try to improve, and we'll move to the final optimized code of the Singleton pattern. Okay, so let's start. Let me explain you first. Okay, so what Singleton pattern is all about. Let's say you are having a class or you are having a project. Okay, this is a project. Inside that there can be multiple class C1, C2 and C3. Okay, so inside each and every class you need to print something. So inside each and every class you will be declaring logger1, logger2, logger3. Okay, and printing something with the help of this logger instances. Okay. Instead of that, you could have done is you could have initialized one logger object and used inside all of the classes. Okay, that is the whole point of this Singleton pattern. Okay, so let's read some points. So imagine you are building an application and you have database connection manager, loggers, database connection managers, loggers, configuration manager. So do you really need to have 100 copies of these objects inside each and every class where you want to use it? No, na? So no, because all users should write logs, all modules should read the same configuration, and all components should use the same cache. Okay, so what is the core problem that Singleton pattern solves? So it guarantees that only one object of a class exists. Okay, if there is a class logger class, so only one object of a class will exist and the global access of this instance will be provided inside the project. Okay, I hope this is clear. So this is the entire motivation of the Singleton pattern. Let's read the definition. So definition also says the same thing, that only one instance of a class exists and the global access point is provided to that instance. So what used to happen before Singleton pattern, how developer used to manage objects. Okay, so let's say there is a logger class, the same example which I have given. So there will be 3 logger instances which we have instantiated inside each and every class. So there will be logger1, logger2, logger3, but we don't want it. Okay, we want only logger object 1, and the same logger will be accessed inside each and every module. Okay, so this is the main crux, what used to happen and what we want as is and to be. Okay, so this is the simple UML diagram. There will be an instance variable inside the Singleton, okay, class, and there will be a constructor and there will be a method. Okay, this is the method, this is the constructor, this is the instance variable. Okay, now let's move to the code. This is the most important part. Okay, this is the vague code that I have written in order to explain what is the drawbacks or what is the problem inside this code, so that we can move to the optimized one. Okay, at the single point of time it will make you feel that this code is self-satisfactory and this is solving the problem, but I'll tell you where is the problem. Okay, so now let's see the code. Okay, so this is the private static Singleton instance. This is the instance variable that we have declared. Okay, this is the constructor that we have declared. Inside this we are printing object created. So inside the main method, what we are doing, Singleton s1 is equals to Singleton dot get instance. This is the first time we have called. Singleton s2 is equals to Singleton dot get instance. Our main idea of this Singleton pattern is to restrict the user in order to create multiple objects. Okay, so this is the implementation that we have done. So Singleton.get instance, whenever Singleton.get instance will be called, the empty constructor will be called. Okay, the first and foremost step is the empty constructor call. Okay, so empty constructor will be called, object created will be printed here. Okay, I hope this is clear. Now as soon as the get instance will be called, it will check that instance double equal to null. This instance double equal to null, because this is the first time we are calling the get instance, means that instance will obviously be null, and we are going to initialize instance is equal to new Singleton. Okay, we are initializing the object. Now s1 will contain the object of new Singleton. Okay, the type here is also Singleton, so we can store the Singleton object inside the instance. Now whenever the next time Singleton s2 is equal to Singleton.get instance will be called. Okay, now in the next time this Singleton get instance, inside this if instance double equal to null, we can see that okay, instance is now already initialized and it already contains the singleton object, so it will not initialize this or make this object again, rather s2 will contain the instance, means the same instance which will be created at the first go. Okay, let me repeat it again. So at the first time we have got returned the new object. Okay, the second time when we see that if instance double equal to null, this is not the case, this is not true because instance is already been initialized. So what will return? Will return directly instance. So ideally if we'll do system.out.println s1 double equal to s2, that means it is true because both is pointing to the same object. Okay, now you will say that okay, so if this is the case or if this is the MVP of this singleton pattern, then we have already achieved. Then what is the point of optimizing this code? Now let me introduce you with the thread. Okay, so there is the problem in multi-threading. The implementation above is not thread safe. Why it is not thread safe? Let me show you. So this is the bytecode simplified, that what is the steps that we are following inside the code in order to implement this. Okay, so this is the first part. Read the value from the memory. Okay, read the value from the memory, that what is the single instance, whether it is initialized or not. Okay, then we are comparing that the value is null or not. Okay, then we are initializing the singleton object. Okay, then we are invoking the constructor. Okay, then we put static instance, and we are pointing or we are storing the object that is created inside the variable. Okay, this is the fourth point that is getting followed. Now listen it very carefully. Okay, the failure scenario. So let's say T1 has started the call. Okay, so T1 has started the call, and you all know that multiple threads can be run simultaneously. Okay, or we can say asynchronously. Okay, so T1 has started the call and it is in step 1. So inside the step 1 it will call get static instance. Okay, read the value, try to read the value of static instance from the memory. Okay, now step 1 is complete, it has read the value. Now it will check that compare value to null. Okay, it will check if instance double equal to null. Okay, at the first time in the step 2 it will get that instance is double equal to null, means instance it is not initialized yet. Okay, till now it is clear. Now as soon as the thread will go to step 3, there will be a, you can read this point. Okay, you can read this point. Thread 1 is preempted, paused by the OS scheduler right before step 3. As soon as it is going to create the object, the thread 1 means, let me erase this. Okay, so thread 1 has checked whether instance is there in the memory or not. Thread 1 has checked whether this is null or not. Okay, as soon as it is going to this line, OS told the thread 1 to pause for some time. Okay, meanwhile thread 2 begin execution. Okay, thread 2 begin execution. Thread 1 is already in this step. Thread 2 has also got this access to enter in this step. Okay, you can read here. Okay, thread 2 begins execution. It executes step 1 and step 2 because thread 1 has not yet reached step 5. The right instance is still null in the memory. So thread 1 is being stopped here by the OS scheduler. Okay, but thread 2 has also reached till step 3, 4 and 5. It creates an object and store it in the static variable. Now as soon as thread 2 reaches here, it initializes the instance as new singleton. Okay, it has done step 3. What is step 3? New singleton object. What is step 4? Invoke constructor. We don't know that who has invoked this constructor. Okay, but object created is printed. Now it has reached to step 5. Put static instance, write the object reference back to the static variable. Now the instance, in the instance variable, it has stored a new singleton. We are talking about this thread 2. Now the scheduler again told thread 1 to resume. Now thread 1 is here. Okay, thread 1 is here. Thread 1 has also created or also has initialized instance is equal to new singleton object, means two times the object is getting created, one by the thread 2, one by the thread 1. Now instance is again getting override. Okay, thread 1 resumes, it already passes if check because the starting point is from the thread 1 itself. Okay, so it proceed to step 3, it creates object B and executes step 5 and overwrite object A. So let me tell you one thing. Okay, so instance is first pointing to obj A. Okay, which is created by thread 2. Now just because thread 1 has also created, now instance has overridden object A to object B by thread 1. So can you see that the singleton pattern is broken? can you see that this singleton pattern is getting brought? Why? Because thread 1 and thread 2 both have created the object. Okay, so I hope this is getting a bit clear. So what is the solution? Okay, so what is the first optimization that we can do in order to move forward? Okay, so the first initialization is, you all can notice that what is the problem with this code. Okay, this code problem is only one object. Whatever the first object that is created should stored in the instance. Why the object B is getting overridden? So you will say simply that make instance variable as final. Okay, so the solution, first solution is, if we would have made instance variable as final, instance, let's say thread A or thread B, no matter, they have created the object A. Okay, with the example that I was explaining, thread 2 has created object A. Now when thread 1 will be executing this instance is equal to new singleton and trying to override this object, the final keyword will restrict. If thread 1 is trying to override this, the final keyword of the instance will restrict. The final keyword will say that, okay, no, you cannot override this content, because once it is initialized and that is final. We have achieved a simple MVP. Okay, that is, whatever the first object is created at the first time, we are going to use that only. Okay, still we have created two objects because still this is not thread safe. Okay, let's see the implementation. What I have done here, public static final string version, this is the first instance variable that I have declared to show you why this is the bad code, or we cannot say that this is the bad code, but this is not properly optimized. Okay, so public static final string version 1.0.1, public static final singleton instance, this we have declared instance as final. Okay, you can see here the code. Okay, the instance, the variable, this is not final. Okay, but here what we have done, we have made it as final. And one more question that I still need to answer, why the constructor is private. Okay, I have written but I forgot to explain. Okay, so now public static singleton get instance. Okay, the instance variable, let's read the point, the instance variable initialization is executed during this logged phase. Okay, so the instance variable initialization, this instance variable initialization is executed during this logged phase, means whenever this singleton class is getting logged by the JVM, that time only instance variable is getting initialized. So no matter if 10 threads call singleton.get instance, at the exact same time, the JVM ensures that the class is initialized once by one thread while the others will wait. Okay, so now public static singleton get instance, return instance. Okay, so now we'll see what is the problem with this code. Okay, so the problem is, if you call system.out.println singleton.version. Okay, so if you'll call singleton.version, okay, just printing singleton.version, even if you haven't called this get instance, then also this instance variable will be getting initialized. Okay, so the JVM loads the singleton class. Now because instance variable is a static field, it will be initialized immediately as soon as we call singleton.version. We want to print version, we don't need anything to do with get instance, but still instance will be initialized. This is known as the eager initialization. Okay, now result, you create the singleton object even though you didn't call this get instance. I hope this is getting clear. What is the problem with this? The only problem with this is eager. Even we can say this code as thread safe. When this JVM is in the class initialization phase, it will lock this singleton. Okay, this is the inner implementation of the JVM, that it will lock the singleton and it will call the get instance. No other thread is allowed to access this get instance at the time of class initialization phase, which is done by JVM. So we can say that this is thread safe. Okay, this is thread safe, but the only problem is this is eager initialization. Okay, now let's move to the second optimization that we have done. Okay, now in order to make it complete thread safe, what we have used synchronized. So why we have moved to optimized code, let me explain you why. So from the solution 1, okay, the code 1, what we have done, object A is also created by thread 2, object B is also created by thread 1, but because the instance variable is final, we are always considering this object A. Okay, that means that outer world will know that, okay, this is the first time the object is created, we are using that only. Okay, means the singleton problem is intact. Okay, in solution 2, what we are doing here, just here, okay, this one, we are restricting thread 2 or thread 1 or thread 3 to create object. Okay, all the three will be referring to this single object. Okay, let's say object A. In the first code, what we have done, although the multiple threads have created the object, but every time we are referring to the object A just because of this final. In solution to what we are doing, by using the synchronized keyword, it ensures that it will put a lock on this get instance, so only thread 1 will have the access to use this get instance, or any of the thread at a particular moment of time, any single thread have the access to call this get instance. Okay, I hope this is getting clear. Now as soon as, let's say thread 2, as soon as thread 2 call this get instance, it got the object as obj A. Okay, now no two thread, because now if we have, just because we have used synchronized keyword, OS do not have the power to stop the thread 2 and resume the thread 1. Okay, so till then thread 1 have to wait. Now thread 1 will enter as soon as T2 has created the object and completed its write, okay, inside the static variable instance. Now T1 will enter and will see that instance is not equal to null, so it will not enter here and it will return the instance which is nothing but object A. I hope this is getting clear why this is thread safe singleton, and this is also helping us to achieve the singleton pattern. Okay, now what is the problem? What is the problem with this? Because this is, it seems like it is the best approach that we have used, but it is not the best approach. Okay, still some modification is needed and we can still optimize this code. Okay, so now why synchronization fixes thread safety? Let's see some of the points. Okay, so now synchronized ensures that only one thread can execute at a time. Okay, it prevents two threads from creating two different singleton objects. Okay, that I have explained. It prevents multiple threads to create the object multiple times. The third point is problem solved. No race conditions, no guaranteed single instance. All the things, all the keywords of the race conditions, multi-threading, parallelism, concurrency, each and everything I'll be going to start or going to explain inside the thread playlist, which I'll be start uploading the videos. Okay, now what is the problem with this code? Okay, so the overhead comes even after the singleton object is created. Okay, only the single instance of the singleton object is created. Every call to this get instance had to acquire the lock on the singleton class monitor. Okay, let me tell you what happens just now. So let's say T2 has get a lock on this get instance and created object A. Okay, it has to get a lock because we have used synchronized. Okay, get lock means it has used this lock. Okay, now T1 comes again, T1 gets locked inside this get instance. Okay, T1 also get lock inside this get after T2 has completed his executions. Okay, T1 has also get the lock, but because instance is not equal to null, okay, it will not create a object. Okay, T1 fails to create the object. Now again some other thread will come, T3 will come, T3 will again get a lock. Okay, again get a lock, and inside this it also fail. Now again T4 will get a lock, T4 will get a lock. Okay, and it will also try to get an instance, but instance is already initialized by this T2 and it will also fail to initialize this singleton object. Okay, I hope this is getting clear. Now acquire the lock on the singleton monitor every time any thread will try to call this get instance. Okay, check if instance is null, release the lock. Okay, the lock acquisition or release is not free. This is the overhead. We have restricted, okay, we have restricted till here. Okay, we have restricted any of the user to create the multiple objects. Okay, multiple singleton objects, but any thread will come, it has to acquire this get instance lock. Means any thread will come, lock it, will check that instance is initialized or not, and then will proceed further. But that overhead of acquisition or release is very cumbersome. Okay, and that is not free, and that is the problem that we are going to solve this by optimizing it further. Okay, let's move to the most optimized code. Okay, this is the most optimized code that I'll be explaining you, and I'll be doing a simple dry run also. Okay, now before that let me explain you why the constructor is private. Okay, if the constructor is not private, then from the outside world any of the user can do singleton s1 is equal to new singleton, can call this constructor, okay, and create this object, but we want to restrict it. So what we have done, we have used this private, okay, not this one, we have used this private singleton. So this is the only reason why we have declared private constructor. Why? Because we don't want the user to create the object from the outside world. Then there is no point of saving the singleton pattern. Okay, the MVP of the singleton pattern will be broke. Okay, so that is the reason why we have created this constructor as private. In notes also I have written, you can refer these notes. And one thing, each and every point I will write in the notes, so that whenever you will try to refer the notes, you will get a complete picture. Okay, what is the steps of understanding this complete method, complete code. So let's see the most optimized code, which is also known as Bill plug method. Okay, this is just the naming which is given to this code. This is the way we have written the code. Okay, so let me tell you the advantages first, then we'll move to the code. Okay, the advantages is it is lazy loading. It is not like eager loading which we have seen just now. Okay, this is thread safe, no synchronization overhead, JVM handles everything. Okay, these are the 4 advantages that we are going to see in this code. Okay, so the class singleton, this is same. Private singleton, this is also same. The constructor is private, the class is singleton. Till here it is same. Now this is the static in the class which is holder. This is the part which helps us to do the lazy initialization. Okay, so just wait and watch what we have done. So inside this private static class holder, we have declared a private static final singleton instance. Final, you can see here, final singleton instance is equal to new singleton. Okay, so singleton instance is equal to new singleton, and outside that holder we have declared one method, public static singleton get instance, and that is returning return holder dot instance. I'll explain you the flow of code. Okay, so from the outside world we have called, let's say we have called singleton dot get instance, singleton dot get instance. Now let's see what will happen. Let me erase this and we'll see what will happen. So as soon as this singleton dot get instance will be called, what will happen? This get instance will be called. Inside this holder dot instance will be called. Inside this holder dot instance will be called, and new singleton will be initialized to instance and it will get returned. Okay, just because this is final, it will hold only single initialization of this instance. Okay, no other thread can override it. Okay, now let's see the implementation, deep implementation. Then I'll be showing some of the points that I have written in order to explain this completely. Okay, let's see the complete implementation. Okay, so JVM class state table. Okay, for every class JVM maintains some table. Okay, that this class is, okay, this is initialized or not. Being initialized means by a specific thread, or it is already initialized, or initialization failed means error. So let's say same going through this, thread A calls get instance. As soon as thread A calls get instance, okay, it reaches here. Moving to second point, it tries to access holder dot instance. Thread A. Okay, till here thread A is there. Okay, JVM checks its internal state, is classed holder initialized. Okay, this state it will ask, is holder initialized? We'll get an idea that no, because this is the first thread that is going to access the holder dot instance, so it will say no, it is not initialized. Then JVM acquires an internal class initialization lock, okay, which I have explained in the second part of the optimization. Just because when the JVM acquires the lock on singleton, it will get a lock on this. It is the JVM overhead to get a lock on this get instance and will initialize this holder instance. Okay, so the same thing written here. So JVM acquires an internal class initialization lock on that get instance. So thread A creates a singleton object and assign it to static final instance. So that thread, there is no OS interruption in between, just because this class initialization lock which is happened by JVM, so OS cannot intervene. Okay, thread A has created this singleton object and initialize it to instance variable. Okay, now JVM updates the table class holder. I'm sorry for that. Class holder is now initialized means, so now the JVM will update that class holder is now initialized. Now JVM will release the lock. Okay, till here it is clear. Now just because thread A has started and it is completed, just because of the help of this JVM class initialization lock, we can say that this is thread safe. This is thread safe. Okay, now thread B will come 1 millisecond later. Thread B calls get instance. Okay, thread B calls this get instance. Okay, now what will do? Thread B calls get instance. It tries to access holder instance. Okay, now JVM checks its internal state, that holder initialized, so it will say yes, holder is already initialized. Okay, now JVM skip this initialization logic. If the holder is already initialized, okay, it will give holder dot get instance. From where it is give? It simply goes straight to the memory address where the instance is stored and returns it. From where this thread A has initialized this instance variables, the same place the thread B will go and get the instance variable, which is nothing but storing the new singleton. I hope this is getting clear, each and every flow how it is working. Okay, so now let's see some points. So why private constructor? prevents outside code from creating new objects with new singleton. Okay, only the class itself control instance creation. Okay, I hope this is clear. Just because we want to restrict the outside world to create this singleton s1 is equal to new singleton, singleton s2 is equal to new singleton, so we have declared private constructor. Now define the nested static class, this holder, nested static class. Okay, the class is not loaded until it is referenced. Until this is referenced, the class is not getting loaded. Okay, that is why it is called lazy initialization. Because the instance field is final, it cannot be reassigned. Because the instance field is final, it cannot be reassigned or override. Okay, because it is static, it belongs to the class, not an object. Because this is static, so it belongs to the class, this holder class, not any object. So we'll be able to directly access this, it holder dot instance. We don't need holder object to call this instance or to return this instance. Just because this is static, holder can directly use this instance. I hope this is clear. Now because it's inside holder, it's created lazily only when holder is referenced. Because it is inside holder, instance is inside holder, it will be created lazily only when the holder instance is getting called. Okay, I hope this is getting clear. Each and every word, why we have used this static, why the constructor is private, why we have used this keyword static, why we are returning this holder, why we are able to access holder.instance directly, why this is static. Okay, because we want this singleton to use this get instance directly. We don't want get instance to depends on the object of the singleton. I hope this is getting clear. Okay, I hope this is getting clear. Okay, now let's move to some of the points and we'll see the final code example and we'll wrap up this video. Why and how it is thread safe? So lazy loading, holder is not loaded until get instance is called. This I have already explained. Now JVM is class initialization. This is the main part why this part of code is thread safe. Okay, let's see. When the holder is loaded, the JVM locks the class object, so only one thread access it. This is the main part, and I'll go very deep inside the thread playlist when I'll be explaining each and every point, and I'll also explain the synchronized keyword internal flow. Okay, so just stay tuned and watch when I'll be uploading the thread video inside the thread playlist. Okay, I hope these 2 points are cleared. Okay, so let's see the final code or the real world code that is being used. Okay, so now this is the configuration manager. Okay, that we have talked in the starting, that the configuration manager can be used inside each and every class, and every user will have the configuration manager in order to read some of the properties. Okay, so inside this I have used properties which is private. Okay, this is the hash map. Okay, this is the private constructor. Again, the reason is I don't want any external user to create multiple objects. That's why I have created private configuration manager. Okay, now properties.put in the properties, when there will be first thread, then the properties dot put will be called and properties will be set to this localhost and cache. Okay, now private static class holder, the same pattern that we are following. Okay, inside this we have the instance variable and it will store the configuration manager object. Okay, only once it will get stored. Okay, that same get instance and that same holder dot instance. So this is the get property which is storing the property, which is taking the key and getting the properties from the hash map. Okay, now let's see. So outside world or from the static main class, okay, we are doing configuration manager is equals to configuration manager dot get instance. Directly we have called get instance with the help of this class. Okay, that is the point, or that is the use of marking get instance as static. Okay, marking get instance as static. So as soon as we'll call configuration manager dot get instance, you'll see, let me show you. As soon as we'll call configuration manager dot get instance, holder instance will be called. As soon as this holder instance will be called, till now this is called as lazy initialization, because just now we have called holder instance. Now holder instance will be called. Okay, it will create the new configuration manager. Now this holder instance will store the object of the configuration manager. Now what will happen? Instance is initialized as configuration. As soon as this new configuration manager is called, the constructor will be called. The constructor will set these two properties inside these properties. Okay, and finally what we are doing, system.out.println configuration.get property, we have passed this db URL. This is the key and this is the value. This is the value. So we have passed db.url. This db.url get passed here. This db.url get passed here. Properties.get db.url get passed here. I'll get jdbc mysql localhost. I'll get jdbc mysql localhost. Now what is the key takeaways that we can take from here? This is thread safe. Okay, this is lazy initialization, lazy init. Okay, This is restricting other users or outside users to create multiple objects and no race condition, which is same as thread safe. So I hope whatever I am trying to explain, it is clear why this is constructor is private, why the holder is static, why the get instance is static, why we have called directly configuration manager.get instance. Okay, each and everything is clear. Okay, so the intent of the video is to explain you singleton pattern. Okay, I have started from this code, the very vague code, and I have explained what are the flaws in this code and moved to the next part of this code, this one. And then we have moved what is the flaws of this code, and then we have moved to this synchronized keyword. We have used make it thread safe, and then we have seen what are the flaws in this thread safe singleton, and we have moved to build plug method, which is the best optimized code that is out there. Okay, that is used in the real world. So I hope I have explained it better. So thank you for watching and having patience. So thank you so much.